Hi, I'm Dennis Wade, and we're at the Storage Visions 2013 conference in Las Vegas, Nevada, associated with the Consumer Electronics Show, which is the largest consumer show in the world. And I have with me right now Brent Welch, and Brent's with Panasys. And Panasys has been one of the speakers today at the show and has given us an overview of some of their new technology, where they think the markets are going. And it's a storage-centered conference, so most of what you're hearing is from storage, the expansion of storage, and where we might go for the future. So with that, Brent, I'm going to have you explain a little bit about your company and your products.
All right. Hi. Thanks, Dennis. Yeah, Panasys, I'd like to say, is a file server for supercomputers. Okay, so what people do in the high-performance computing space is they use lots of computers to all work together on a problem, whether that's rendering movie frames or looking for oil and gas deposits, or building an airplane, or doing financial simulations. And so we've taken the same approach for our storage product, where we have lots of computers that all have a little bit of storage. They all work together to provide a high-performance storage system. We've been working on this for a long time, dating back to research with RAID and with network-attached secure disks that evolved into object storage devices. And we built a high-performance parallel file system on top of object storage. And it's different object storage than the cloud objects, although many of the ideas are the same. And we've taken the ideas from our parallel file system and included them as part of the NFS version 4.1 standard, so that we can bring high-performance parallel I/O to the NFS standard in PNFS. We've been working on that for quite some time, and that's just now percolated all the way upstream into the Linux kernels, and is about to percolate back down through the distributions. And we did our RFCs back in January of 2010 on PNFS. Our product is hardware and software. We have a blade architecture. Each storage blade has 2 high-capacity SATA drives and an SSD and an Intel processor and gigabit networking built into a chassis that has dual redundant power supplies and a battery, and 10 gigabit uplinks. And you can take any number of those chassis and aggregate them together into as big a storage system as you need. Right. So Right, exactly. We have our biggest single installations are about 100 chassis, so that's 1,100 blades, 2,000 disk drives in one storage system, delivering above 100 gigabytes a second of aggregate throughput to the applications. So it's fun. It's a fun space to be innovating in. We have, in our current generation, we've integrated an SSD. We first did that in 2009, actually, and we have a new version now, and we have anywhere from 1.5% SSD to SATA drive ratio to 10%, depending on the configuration of the blade. And because the file system is layered over an object store, we know what we have when we store it. So unlike a traditional block-based SAN array, which is just trying to figure out which blocks might be best to put on an SSD, we kind of know from the get-go whether this is metadata or a small file. Right, exactly. So we use the SATA drives for large data extents, and they're great for that. They have good bandwidth, they stream data in and out of them. But all the complicated data structures and small files and little things that cause problems for a disk drive because you have a seek problem, we can concentrate that on the SSD, and so we use the 2 different kinds of storage media for what they're good at, and as a result, we have a very high performance system.
Which means you can also pretty much design your own cost performance structure for each individual client based on what he needs at the time, and it can be expandable, and it's transparent to him, so he doesn't know or care, but he gets the performance he needs, he gets the capacity he needs, and he's able to a little bit determine the price he's paying for it.
That's right. Yeah, so we automatically manage that. The system is expandable. You can add storage to the system, and it will automatically rebalance existing capacity across the new storage elements. And if you had the system for a while, you can add new generation hardware and then quietly migrate your data off the old generations in the background while the system's online. We do, there's always a performance cost trade-off, and traditionally our knob is turned all the way over towards the performance side. We have a little bit of flexibility, so we do have different cost points. But some people in the storage business, it's often always dollars per gigabyte, and people look at the raw cost of a hard drive, which is pretty cheap. I think now that people are realizing the value of SSDs and the value of storage, the dollar per gigabyte, we have a very good dollar per gigabyte actually, with many of the performance characteristics of SSD, so it's a nice hybrid solution.
And it looks like, based on that your future looks very good in terms of going into higher and higher performance requirements with the entertainment industry. You mentioned aerospace industry. You mentioned some of the mining and industrial industries that we have in the U.S., which are on the high level of their requirement range. And it looks like that's going to continue. So a lot of high-end servers and high-end processors are based on your equipment and your architecture.
Yeah, that's right. We have customers, for example, Intel. Every processor that's been taped out since 2006 has been using Panassa storage. For example, when you compute the mask for a chip, it's say a 20 nanometer technology. Well, they're shining light at a 150 nanometer wavelength through a very fine mask, and it doesn't make nice clean shadows. It makes funny blobs and interference patterns. So they actually have to simulate the physics of the light going through that fine-grained mesh, see if it hits the substrate, with the right shape. Of course it doesn't, so they have to iteratively refine the mask until they get the right crisp lines that they want. And that's very computationally intensive and also very storage intensive. There are many applications like that, seismic data processing, computational fluid dynamics. Yeah, Boeing is a big customer of ours. We have a bunch of Formula One teams that use our storage to do, simulation of their cars, and hedge funds that do Monte Carlo simulations. So there's a lot of different applications.
Brent, thank you. Thank you very much. It's been very interesting, and I'm sure we'll enjoy your comments. Thank you.
All right, thanks.